Okay, we are going to learn section 4.3, deriving inverse trig functions. This section is broken into two parts as derivatives of inverses of functions, which we're going to look at through sort of an exploration activity, guided activity with some practice problems. And then there's the other piece of it is deriving inverse trig functions. So let's derive inverse trig functions. One thing I tell students with these functions is that they're really obnoxious and you really don't need to memorize them at this point. Put them on a sheet of cardstock and your sheet of cardstock that you've been hopefully keeping track of. If not, just leave them in your notes. And then when it gets close to the day of the AP test, just memorize them for a few days, do some flashcards or something, and then forget about them. So they don't come up that much either. Before we do that though, quick reminder, arc sine, arc cosine, those mean the same thing as inverse sine. So arc sine of x is the same as inverse sine of x. Remember, this is different than 1 over sine. 1 over sine is the reciprocal of sine, which is cosecant. Okay, this means literally the inverse of sine. All right, I'm going to typically err on this notation here, the inverse notation instead of arc sine, just because it makes it abundantly clear that we're talking about an inverse. So let's start. The derivative with respect to x of, and I'm going to give you the derivative of inverse sine of u, where u is some function in terms of x. And I'm going to do that because once you have the derivative of inverse sine of x, it's just not a question that's going to come up that often because it just is what it is. Usually when they're going to ask about derivatives of inverse sine, inverse cosine, inverse trig functions, there will be some function inside of it as well. In other words, it will be a chain rule question. So this will be equal to 1 divided by the square root of 1 minus u squared times u prime. It is not pretty. I did not promise that it would be pretty. Next, we're going to go through and do tangent. Now, you might be expecting cosine. In fact, the first time I did this video, I wrote down cosine and botched the whole thing. But we're going to go to tangent, inverse tangent right now, and I'll show you why in a second. The derivative of inverse tangent is 1 over 1 plus u squared times u prime, the derivative of u. And then we're going to go to secant. The derivative of inverse secant is secant of u. Now, if you thought the first two were bad, wait until you see this one. It is 1 divided by the absolute value of u times the square root of u squared minus 1. All of that times u prime. Okay? So then I'm going to take and I'm going to show you the derivative of the cofunctions now, okay? So let's go separate this out here. All right, so here's the cofunctions. The derivative of inverse cosine is equal to negative 1 over the square root of 1 minus u squared times u prime. And the reason I gave them to you in this order is because the cofunctions are the same as the originals, except they're the opposite sign. Okay, so when we take the derivative of cotangent, inverse cotangent, which, by the way, if inverse sine and inverse cosine are not that common, inverse cotangent is even more so, or less so. Anyway, so the derivative of that will be negative 1 over 1 plus u squared times u prime. And then the last one, the derivative of inverse cosecant is equal to negative 1 over the absolute value of u times the square root of u squared minus 1 times u prime. Sorry, that's kind of poorly written there, but times u prime. Okay? So there's your formulas for the derivatives of inverse trig functions. Now I just want to do an example or two, and then we'll call it good. So let's see here. Example 1. Let's take the we're going to take the derivative. F of x is going to be the inverse sine of x squared. Okay, so take the derivative of that. Check my formula. The derivative of inverse sine is 1 over the square root of 1 minus u squared. So we'll be a little bit careful, but all we're doing is dropping in x squared in for u. So it'd be 1 over the square root of 1 minus u squared. That's going to be x squared times the derivative of u, which is 2x. And then I'm going to clean that up. So f prime of x will be equal to, I'm going to put 2x in the numerator. On the bottom, I've got the square root of 1 minus x to the 4th. And that's it for the derivative of that one. Okay. Last example I want to do here is, let's suppose we have a position function. So let's suppose we have a position function x of t. So x of t is going to be equal to tangent, inverse tangent, of the square root of t. That's a cursive t, by the way. All right, and we want to find the velocity at t equals, wow, that was loud, at t equals 16 seconds, okay? So all this amounts to is just taking the derivative of the position function and then evaluating it at 16. So let's do that. So v of t will be equal to, the derivative of tangent is 1 over u squared. That one's not so bad. So, sorry, 1 over 1 plus u squared. So that will be 1 over 1 plus the square root of t squared times the derivative of u times u prime. So that will be, so just make a quick note over here, I guess. Remember that that's t to the 1/2 that we're deriving, okay? So I'm going to end up with 1/2 t to the negative 1/2 for the derivative, okay? I'm going to clean that up before I plug in 16. You could do it right now, but I think you have to clean it up anyway, or most of you probably will, or I want to. So what I get here is 1 plus t, square root squared is just t, and then times, so this is t to the negative 1/2. That's the same as 1 over t to the 1/2, which is 1 over the square root of t. So I've got this 1 over 2 square root of t. And you can combine these together if you want, but I think this is good enough. We're going to plug in 16 now. So v of 16 is equal to 1 over 1 plus 16 times 1 over 2 times the square root of 16. Plug that in, simplify. I'm going to end up with 1 over 17 times 1 over, let's see, 2 times 4 is 8, so 1 over 8. Oh boy, can I do that in my head? Let's see. So that's going to be 1 over 80 plus 56, 136. 1 over 136. Check that again, 80 plus 56. I should have that written down. Yeah, I think I'm right. Okay, and so that's going to be your final answer for v of 16. Okay. As usual, if you have any questions on this video, please let me know in class or via email, and I can sort it out. But that's really all there is to it for derivatives of inverse trig functions.